Hello, 5th grade math students. This is Chapter 7.2, Equivalent Ratios. In Chapter 7.1, you learned how to write ratios, and today you'll learn to identify equivalent ratios, or ratios that have the same values. Let's begin. Equivalent ratios show the same comparison of numbers or quantities. So we'll begin with Jack having 4 red apples and 8 green apples. The ratio of the number of red apples to the number of green apples is 4 to 8. Now, Jack's going to put 2 apples of the same color on each tray. When he's divided the apples onto the trays in this way, we now have 2 trays of red apples and 4 trays of green apples. Now we would write the ratio of red apples to green apples as 2 to 4. 2 trays and 4 trays. Finally, Jack has decided to put 4 apples of the same color onto a tray. When he puts the apples onto trays in that way, he has 1 tray of red apples and 2 trays of green apples. The ratio of red apples to green apples will now be written as 1 to 2. All 3 ratios, 4 to 8, 2 to 4, and 1 to 2, compare the same numbers of red apples and green apples. These are equivalent ratios. 4 to 8 is equal to 2 to 4, which is equal to 1 to 2. The ratio written in its simplest form is 1 to 2. The ratio that shows the actual numbers of red apples and green apples is 4 to 8. Here's a similar problem to work through on your own. Problems 1 and 2 are on this page, and problems 3, 4, 5, and 6 will be on the next page. So press pause while you work problems 1 and 2, and then go on to 3 through 6. In this problem, you'll see that we have pencils and push pins in different quantities that we're comparing. We begin with the largest groups that show the actual numbers of pencils and actual numbers of push pins. Then we begin breaking them into units or groups. Okay? So go ahead and work 1 and 2, press pause, and numbers 3 through 6 will be on the next screen. And here's the last portion of this practice section. Now you have the final simplest form groups in number 3. There I gave you a little hint for question 5. And then you're asked here to write the 3 equivalent ratios that you've created. Then answer in number 5 which ratio is in the simplest form. And in number 6, write the ratio that shows the actual numbers of pencils and push pins. Press pause while you work, and when you come back, we have one final idea for this chapter. Now let's learn to use the greatest common factor to write ratios in their simplest forms. We'll begin with the ratio 4 to 6. Find the ratio 4 to 6 in simplest form. So to write a ratio in the simplest form, we want to divide the terms by their greatest common factor. So what would be the greatest common factor of 4 and 6? It would be 2. 2 is the biggest number that goes into both 4 and 6. So we'll divide 4 by 2, and we'll divide 6 by 2, giving us a new answer of 2 to 3. So the simplest form of the ratio 4 to 6 is 2 to 3. We know we found the simplest form because the numbers 2 and 3 cannot be divided by any common factor other than 1. So a ratio is in its simplest form when the terms only have 1 as a common factor. Another example would be to find the simplest form of the ratio 5 to 10. What is the greatest common factor for 5 and 10? It's 5. So we're going to divide 5 by 5 and 10 by 5 to get our new ratio, which will be 1 to 2. We know that this is the simplest form because the only common factor shared by 1 and 2 is 1. Okay, let's try some of these on your own. For problems 7 and 8, please find the ratio in simplest form. Press pause while you work, and next we're going to fill in missing terms in a ratio. Let's say we're given a pair of equivalent ratios, but one of the terms is missing. How would we go about figuring out what the missing term would be? The first method is to use multiplication. So let's look at the terms in our equivalent ratios. 2 to 5 is equal to 6 to what? We don't know. First, let's find our multiplying factor. What do I mean by that? I mean, what factor have we multiplied 2 by to turn it into 6? Well, we've multiplied it by 3, right? 2 times 3 equals 6. So if we've multiplied 2 by 3 to get 6 as our first term, we're going to do the exact same thing to 5. We're going to multiply 5 by 3, and our next term will be 15. We can write this in another way. 2 to 5 is equal to 6 to question mark. We'll just leave it blank for now. We're going to take 2 times 3 to get 6, so we'll do the same thing on this side. 5 times 3 gives us 15. Okay? So 3 is what we'll call our multiplying factor, and that will tell us what to multiply each term by to get the new equivalent ratio. Now let's find the missing term in these equivalent ratios. 15 to 12 equals question mark to 4. In our first example, the first ratio was smaller than the second ratio. In this case, the first ratio is larger than the second ratio, so multiplying isn't going to necessarily work. It might be easier to divide. So let me show you how to use division to find our missing term. So first we want to look at the terms in our ratio. 5 to 12 is equal to unknown quantity question mark to 4. So what is our common factor between 12 and 4, the two numbers that we can compare? It's going to be 3, right? We're going to divide 12 by 3 to get 4. So we'll do the same thing with 15. We'll divide 15 by 3 to give us an answer of 5. Okay? You can also write it this way, vertically stacked, if that way works better for your brain. Okay? So we're going to divide each by 3, giving us an equivalent ratio of 5 to 4. Okay? So the missing term is 5. Here are your last 3 practice problems for 7.2. In the first, number 9, please find the missing ratio in the equivalent ratios 4 to 3 equals 20 to question mark. 10, find 7 to question mark is equal to 21 to 12. And in number 11, find the missing term in question mark to 16 is equivalent to 3 to 2. When I see you tomorrow, we'll do more work together on equivalent ratios. Have a great night.